This is the quotient rule for exponents. The quotient rule is obviously sort of the opposite of the product rule. So when I'm multiplying, I added exponents, but now when I'm dividing, I subtract their exponents. Again, they have to have the same base. And let me show you on this first example why this works. If I had x to the fourth on top, that means 4x's on top and 2 on the bottom. And then if I were reducing, I would end up canceling out 2 of the x's, which would leave me with 2 x's left over, or x squared. So instead of having to write that out and cross off the common factors, I take 4 minus 2 because it's division, and I end up with x squared. Try these two on your own, then press play to see how you did. For the first one, 6 minus 2 is 4, so h to the fourth. And for my second one, 3 minus 1, remember put that invisible exponent on there, gives me 3 squared, and 3 squared is also 9. Here's another quotient rule example, this one again involving coefficients. So the coefficients I'm going to treat as sort of a separate problem. If I had 9 divided by 3 or 9 over 3, my answer would be 3. And then I'm going to use the quotient rule on those variables. So 4 minus 2 is 2. So my answer is 3x squared. Go ahead and try these two on your own, then press play to see how you did. For the first one, again, I would divide 25 and 5 to get 5, and then 3 minus 2 to get 1, so it would just be 5x. It's not necessary for us to put the 1 up there, so I would just write that as 5x. For my second example, 18 divided by 3 is 6. And then I have an x on the top, but nothing on the bottom to cancel it with, so it's going to stay right there on the top. And then 3 minus 2 is 1, so y to the first. So 6xy is my answer.